The paper of the day is Bridging the Archipelago Between Row Stores and Column Stores for Hybrid Workloads. It's a 2016 paper. The paper presents a method to bridge the architectural gap between the OLTP and OLAP systems using a unified architecture. Their approach is to store tables using hybrid layouts based on how the DBMS expects tuples will be accessed in the future. This means that a table's hot tuples are stored in a format that is optimized for OLTP operations, while the other cold tuples in the same table are stored in a format that is more amenable to OLAP queries. They then propose a logical abstraction over this data that allows the DBMS to execute query plans that span these different layouts using separate engines with minimal overhead. Their other contribution is a novel online reorganization technique that continuously enhances each table's physical design in response to an evolving query workload. This enables the DBMS to migrate the database to the near optimal storage layout for an arbitrary application without requiring a human administrator to configure the DBMS for the particular application and in a transactionally safe manner. Authors implemented their execution engine and the FMS storage manager in the Peloton DBMS. Peloton is a multi-threaded in-memory DBMS that is designed for HTAP workloads. Now moving on to the benchmark. They developed Adapt benchmark that is composed of queries that are common in enterprise workloads. This benchmark is inspired by the one Elagianis and all developed for evaluating the HDO Adaptive Storage Manager. The Adapt database has two tables, a narrow table and a wide table. Each table contains tuples with a primary key and p integer attributes, each 4 bytes in size. The narrow table has p equal to 50 attributes and the wide table has p equal to 500 attributes. The size of the tuples in these two tables is approximately 200 bytes and 2 kilobytes, respectively. In all of their experiments, they first load 10 million tuples into each table in the database. Now looking at the contribution. This paper presented a DBMS architecture based on tiles to bridge the architectural gap between the OLTP and OLAP systems. The FSM storage manager stores tables using hybrid storage layouts based on how it expects the tuples to be accessed in the future. It organizes the hotter tile groups of a table in a format that is optimized for OLTP operations, while the colder ones are stored in a format that is more amenable to OLAP queries. They propose a logical tile abstraction that allows the DBMS to execute query plans over data with these different layouts without using separate execution engines and the minimal overhead. Their online reorganization technique continuously enhances each table's physical design in response to an evolving query workload. This enables the DBMS to optimize the layout of a database for an arbitrary application without requiring any manual tuning. The evaluation showed that the FMS-based DBMS delivers up to 3 times higher throughput compared to static storage layouts across different HTAP workloads. Now, looking at the PS score, overall it's a nice read with some dense parts, so it gets 8 out of 10 on readability. With 16 pages long, it scores 7 out of 10 on length. Reproducibility and repeatability will be a bit challenging, so it gets 6 out of 10. Industry value is low as the approach is not proven in production and was implemented in Peloton project, which got shelved, so it gets 4 out of 10. Learning meter is decent, so it gets 6 out of 10. Overall PS score is 6 out of 10.